Hey guys, today's topic is 2.1 Rates of Change and Limits. We're going to start this lesson off by doing the quick review, page 65, numbers 1, 3, and 9. Check your answers in the back of the book. Pause this video until you have done these problems. Average speed is the distance over time. On an interval from A to B, average speed is equal to f of B minus f of A over B minus A. Now, if an object dropped from the top of the Empire State Building's distance is modeled by d equals t squared plus 2t plus 1 feet per second, what is the average speed in the first 5 seconds? In this case, A to B is 0 to 5. So, we do f of b, which is 5 squared plus 5 times 2 plus 1 minus 0 squared plus 2 times 0 plus 1 over 5 minus 0, which simplifies to 25 plus 10 plus 1 minus 1 over 5, also known as 36 minus 1 over 5, or 7 feet per second. Now, how about between 3 and 5 seconds and 4.5 and 5 seconds? Pause this video until you've figured these examples out. Between 3 and 5, it should be 10 feet per second, and between 4.5 and 5, it should be 15.75 feet per second. Now try problem 1 on page 66. Pause this video until you've done so. What is the instantaneous speed at 5 seconds? To figure this out, you'll have to use limits. Now limits, what is a limit? Pause the video now and put the definition of a limit from page 60 into your notes. A limit is the number the function approaches, L, at a certain value of h. Now on this graph, as you approach -2, even though there is a discontinuity right there, it still approaches -4. On this graph, however, since there is a point discontinuity, there is no limit as x approaches this number. Now, our notation for limits is this. Oops. Read as the limit as x approaches h of f of x is equal to L. One way to solve this is simple substitution. Now, the limit as x approaches 2 of 5x plus 4. Let's try simple substitution. So, 5 times 2 plus 4, or 14. The limit as x approaches 2 of this is 14. Now try the limit as x approaches 0 of 3x to the 4th minus 4x cubed plus 9x squared plus 3x plus 2. Pause this video until you have done so. The answer should be 2. Now, warning, simple substitution does not always work. Another way to solve a limit is factoring. Make sure you always try simple substitution first, so it can save you a lot of work. Now, the limit as x approaches -4 of x squared plus 12x plus 32 over x plus 4. Let's try simple substitution first. When we try this, the denominator equals 0. And as we all know, we can't divide by 0, although Mr. Evans keeps promising us that he'll teach us how. So, let's factor it. When you factor this, you get x plus 4 times x plus 8 all over x plus 4. Your x plus 4's cancel, so now you can plug negative 4 into x plus 8 and get 4. Now, try the limit as x approaches negative 3 of x squared plus 9 plus 3 over x plus 3. Pause this video until you've done so. The answer should be 0. Pause this video now and put the properties of limits from page 61 into your notes. Thanks for watching, guys, and this lesson has been brought to you by me, Ray Bennett. And one last thing, go State!